as promised, we're going to look at problems involving the quadratic function. So this will be worked example number 3. What's the question here? Find the equation, and the form is specified. The form is ax squared plus q, defining each of the graphs below. Of course, there are other graphs that are coming up, but I should have probably said defining the graph below, defining the graph below. Okay, so let's go for this. Let's see, what have we got here? It's a parabola, right? So first things first, let's see what is A. A is positive. Okay, and what about Q? We can see that Q is actually positive, but not just positive. Q is actually equal to 2. And you ask, Mr. G, where do you get that? Well, Q is always around the turning point. That's how I know. And I know Q is actually the y-intercept when the parabola is in this form. So already I have Q, so I know ax squared plus 2 is what I have for now. But moving on, actually, I can use this point here. It's on the graph. It's part of the graph. So remember, this is x and that is y. So I can use this point, actually. I substitute for a 1 squared plus 2 to find a. And you agree with me that if you solve this, a clearly it is equal to 2. So therefore, my graph is y equals to 2x squared plus 2. You now know how to sketch. Now we are checking. Given a sketch, can you give us the equation that generated the sketch? Okay, so it's the vice versa of what you were doing last week. Another example, and of course this is a different case. Same story, we've got to find the equation defining this graph, and guess what? Here we are not given Q, but we are given 3 points at least, okay? So we don't really know what that point is, so we've got some bit of work to do here. So let's see what we can do. We know the form is y equals to ax squared plus q. So I'm going to substitute one of the points. I'll take 2 and 0 for now, and obviously y is 0, so if y is 0, and I substitute there, I'm going to have 4a plus q. Now notice, whether you took this point or that point, you will get this equation, because x squared there suggests that even you substitute negative 2, you'll get a 4. Even if it's a 2, it's a 4. So here really you could choose one point. Okay, what I'm trying to say here is to emphasize the fact that you actually need 2 points to find the equation of a parabola, 2 known points. Okay, so this becomes my equation 1. Now I look for equation 2, and obviously I'll use that point. Now remember, a 2.5, guys, is just 5 over 2. So y here is a negative 5 over 2, and I substitute a 3, that's going to be 9a plus q, equation 2. Now, this is why you have to start with equations in term 1. Because when you come to term 2 and discuss functions, you need to have a knowledge of simultaneous equation. So I'm going to use elimination to solve this. Why elimination? Because I can see there's a q here, there's a q here, and they are equal. So I can simply say equation 1 minus equation 2. Okay, and then I go ahead, 0 minus a negative 5 over 2 is going to be a plus 5 over 2. What is 4 minus 9? That's going to be a negative 5a, and of course, there's going to be plus 0 because q minus q is 0. Then you can see all I've got to do here is to now actually divide by a negative 5 on both sides. Now be careful. 5 divided by 2 divided by a negative 5 is actually 5 divided by 2 times a negative 1 over 5, which means a 5 takes away 5 and you're left with a negative 1 over 2. Therefore, you can see here that a is actually a negative half. Of course, you could have pressed this in your calculator to save yourself some stress of algebraic errors. Okay, so you are welcome to actually type this in your calculator. What you could have done, you could have just said 2.5 divided by a negative 5. That's what you could have done. Perfect for me. I'm happy with that, as long as you get the correct answer. So I have my a. Can I find my q? Yes. Which equation? I'm actually going to use equation 1 because it looks very easy. So substitute, remember, substitute a equals to negative half in equation 1. So I have 0 is equal to 4 into a negative half, okay, plus q. Now you can see why I chose this. It's nice. 2 2 goes twice into 4, so I have a negative 2. Therefore q is actually 2. That means this point here is actually 0 and 2. Therefore, what is my final equation? I'll use a different color for this. My final equation is I've got a negative half x squared plus 2. Now go ahead, see if you can get a graph like this if you sketch that. Go for it. I'll catch you guys later. Cheers.